students, my name is Nitesh. Shet. I am from Manavara. So last class we discussed about a topic from 10th standard, that is pair of linear equation in two variables. In pair of linear equation in two variables, we already discussed about definition of pair of linear equation in two variables, and again some of the graphical methods and some of the algebraic methods. So here we already know about how graph appears and how algebraically we have to represent those pair of linear equation in two variables. That means there are some of the intersecting lines. That means that pair of linear equation two variables has a unique solution. Again, there may be a chance of parallel lines. Parallel lines means there is no any common solution for the pair of linear equation in two variables. Again, there may be a chance of lines lying on the straight line when we are drawing the graph of pair of linear equation two variables. That means those pair of linear equation two variables having infinitely many solutions. So, dear students, in this class we are categorizing those pair of linear equation two variables in the form of consistency, inconsistency and dependency. So that means here the same concept arises, that is intersecting lines are there, parallel lines are there, and the lines lying on the same line. So these conditions are there, we are categorizing or we are naming that one as consistency and inconsistency and dependency. So dear students, in this class we have to discuss about consistency, inconsistency and dependency of pair of linear equation in two variables. So consistency, inconsistency and dependency. So we are calling it as consistent, inconsistent and dependent pair of linear equations. So we have to give some of the example and we have to take some of the relation between coefficients, the ratios of coefficients here. So let us discuss about consistency, inconsistency and dependency. So I already told you that when we are taking some of the pair of linear equation two variables, so there may be a chance of intersecting lines. That means the pair of linear equation two variable has only unique solution, only one common solution. So that form of equation or those pair of linear equation we are call it as a consistent pair of linear equation. So that is firstly I will call it as when the pair of linear equation two variables having unique solution is known as consistent pair of linear equation. That is when a pair of linear equation in two variables having only one common solution, is known as so those equations we call it as a consistent pair of linear equation. Consistent pair of linear equation in two variables. Linear equation in two variables. So we know about intersecting line. This is about intersecting line. When we are having intersecting lines as a graphical representation of pair of linear equation two variable, so that pair of linear equation is known as consistent pair of linear equation. So then we move into the next situation, that is parallel lines. That means there is no any common solution. Here there is only one solution is there. So the opposite of that, there is no any solution. That means here when we are getting the parallel lines as the graphical representation of pair of linear equation two variables, so that pair of linear equation is known as inconsistent pair of linear equation. That is when a pair of linear equation in two variables So we know about consistent pair of linear equation and inconsistent pair of linear equation. So again another one case is there, that is infinitely many solution. That means when we are having the graphical representation of pair of linear equation two variables, the lines lying in the same line means there is chance of infinite number of common solutions for pair of linear equation in two variables. So that pair of linear equation we call it as a dependent pair of linear equations. That is third one, it is when a pair of linear equation in two variables having infinitely many solutions. Infinitely many solutions is known as dependent pair of linear equation in two variables. Linear equation in two variables. Yes. So these are the three cases. These are the three important cases of linear equation in two variable. Pair of linear equation in two variable. That is, one is the consistent pair of linear equation and the pair of linear equation having only common solution. So when the pair of linear equation having any solution means it's an inconsistent pair of linear equation. Then when the pair of linear equation having infinitely many solution means the pair of linear equation in two variables is known as dependent pair of linear equation. One dependency. So they depend upon. So one is dependent upon another. So likewise. So we are taking that one. So these are the dependent consistency, inconsistency, and dependency of pair of linear equation two variable. Here we are comparing inconsistency, consistency, and dependency with the ratio of the coefficient of x and y and constants. So let us discuss about how we can compare with consistency and ratios of coefficients. Yes, so here we already know about graphical method and algebraical method, how we can take graphically and algebraically. So we already know about pair of linear equation two variables, and we got whether it is intersecting, whether it is coincident lines, or whether it may be parallel lines. So we already took these examples in the last classes. So when we are taking these two pair of linear equation in two variables, so we got the intersecting lines. Here intersecting lines we got, and so there is only one unique solution. Then here when we are taking this as an example, so we got the coincident line, that means line. So here it is a infinite solution. So there will be infinite solutions are there. So here when we are taking this pair of linear equation two variable, this and this, so we got the parallel lines. So there is no any solutions here. So apart from that, we are categorizing. Already we categorized that. That is, one is the consistent pair of linear equation, another is the inconsistent pair of linear equation, and dependent pair of linear equation. Consistent pair of linear equation means it's an intersecting lines, and when we are taking inconsistent pair of linear equation, it is parallel lines. Then when we are taking the coincident lines means, so it's a dependent pair of linear equation of two variables. There may be a infinite number of solutions. So with the regard of that, on the basis of that, we are categorizing consistent pair of linear equation and inconsistent pair of linear equation, dependent pair of linear equation, by taking the ratios of the coefficient of x, y, and also constant terms. So here just observe, here all the equations, all the pair of linear equation is in the form of ax plus by plus c is equal to 0. that means here. So I will write the standard form here firstly. So that is a1x plus b1y plus c1 is equal to 0. That is one of the standard form of the equation. Another one is the a2x plus b2y plus c2 is equal to 0. Yes, are you agree with that? So here also all the equations are in the form of amx plus b1y plus c1 is equal to 0 and amx plus b2y. Here the constant terms are in the RHS side. No problem. So we are comparing with the ratios of the coefficient. So what happens, we have to know that. So that is when we are taking a1 by a2. So here what is the a1 here? It's a 1 and here a2 is 3. When we are comparing this two equation with a1x plus b1y plus c1 is equal to 0 and 8x plus b2y plus c2 is 0. So here a1 is 1 and a2 is 3. So what is the answer? a1 is 1, a2 is 3. Then, so when we are comparing b1 and b2, so when we are compare those two equations with these two standard equations, here b1 minus 2, b1 is minus 2 and b2 is 4. So that means we got the value as minus 1 by 2 here. Then, so next, so we have to take here C1 and C2. C1 and C2 means here plus, it's in the LHS side, that means we can take its LHS side. So when we are taking 0 as LHS side, it will become minus 0. Is here 0, so only 0 means it's 0. So then, here when we are taking into the LHS side, it becomes minus 20. So that means C1 is 0 and C2 is minus 20. So that means the answer is 0. We got the value here as minus 1 by 2. It is here minus 1 by 2. And here we got the value as 0. Okay, so then let us come to the next point. That is here. So here just compare a1 is 2 and a2 is 4. So that means 2 divided by 4. 2 divided by 4 means it's a 1 by 4. Then when we are comparing with b1 and b2, so it means here b1 is 3 and b2 is 6. 3 by 6, that means we got the value as 1 by 2. Then compare c1 and c2. Here it is minus 9, here minus 18. So here minus 18 cancels here. So we can take like that only. 9 by 18, it means 9 into 1, 9 into 2, that means it is also 1 by 2. Then here, let's come to the third point. So here a1 is 1 and a2 is 2. So that means we got the value as 1 by 2. Then here a1 is 2 and a2 is 4. So here b1 is 2 and b2 is 4. So that means 2 by 4 is equal to 1 by 2. Then here, let us come to the here constant term c1. c1 is 4 and c2 is 12. So that means 4 by 12. That means it's 1 by 3. So it will be true for all the pair of linear equation two variable. Here just compare here. So here 1 by 3 is there, here minus 1 by 2 is there, and c1 by 0. So here none of the ratios of the coefficients of x and y constant terms, here it is not equal. So that means all are unequal here. So that means 1 by 3. So or we can directly take the ratios only. So it is a1 by a2. a1 by a2 is not equal to b1 by b2, not equal to c1 by c2. So when the pair of linear equation holds this condition, there must be a graphically intersecting lines. It has only one common solution. Then, so let us come to the next point here. So it is 1 by 2, here 1 by 2, 1 by 2. All the ratios are equal here. So that means here 1 by 2 is equal to b1 by b2 is equal to c1 by c2. So when the pair of linear equation holds this condition, there must be a constant line. There must be a constant line. So there may be infinite number of solutions. Then let us come to the next point. So here a1 by a2 is equal to b1 by b2, but not is equal to c1 by c2. It is a1 by a2 is equal to we are categorizing this as a consistent and inconsistent pair of linear equation. So that is when the equation holds, when the pair of linear equation two variable holds this condition, it has an intersecting lines, it has a common solution. That means the consistent pair of, it's a consistent pair of linear equation. When the pair of linear equation two variable holds this condition, a1 by a2 is equal to b1 by b2 is equal to c1 by c2, so there is coincident lines and there is an infinite number of solutions. That means those pair of linear equation two variable are dependent pair of linear equation. Dependency. Then, so when the pair of linear equation in two variable holds this condition, a1 by a2 is equal to b1 by b2, but not equal to c2, there is graphically intersect parallel line, algebraically it has no solution. So we are call it as inconsistent pair of linear equation. Inconsistent pair of linear equation. So these are about the comparison between consistent, inconsistent dependence with the ratios of their coefficients. So we are compared like that only. So let us move on to the next topic, that is we are taking some of the problems on some of the pair of linear equation in two ways. 2x plus 3y is equal to 9 and 4x plus 6y is equal to 15. So here it is the pair of linear equation in two variables. Those two equations are having two variables x and y. So I will consider this as equation number 1 and this as equation number 2. So let us consider the standard form of pair of linear equation in two variables. So what is this standard form of pair of linear equation in two variables? That is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. I will consider this as equation number 3 and this is equation number 4 here. So let us compare equation 1 with equation 3 and equation 2 with equation 4. That means compare equation 1 with equation 3 and equation 2 with equation 4. So firstly we have to compare equation 1 with equation 3. So here we have to write value of a1, b1, c1 and a2, b2, c2. So here a1 is 2. When we are comparing equation 1 and equation 3, so a1 is equal to 2, a1 is equal to 2, then b1 is equal to 3, b1 is equal to 3, then c1 is equal to minus 1. So that means when we are taking it into the LHS side, that means it becomes minus 1. c1 is equal to minus 1. So the equation, comparing equation 1 with equation 3 is completed. Then we have to compare equation 2 with equation 3. That is here equation 2 is here. We have to compare both. So here a2, in place of a2 here 4 is there. That means a2 is 4. Then b2 is equal to, here b2, in place of b2 here 6 is there. Then in place of c2 we have minus 8. That means we have to take the becomes minus 80. After that we have to take the ratios. That is firstly we have to take a1 by a2. This a1 by a2 is equal to, a1 is equal to 2, a2 is equal to 4. That means 2 by 4 is equal to 1 by 2. So we got the value of a1 by a2. Then so we have to take b1 by b2. What's the value of b1? Is 3. And what's the value of b2? b2 is equal to 6. So it is also 1 by 2. So after that we have to take c1 by c2. What's the value of c1? It is minus 9. And what's the value of c2? It is minus 18. Minus 18 is equal to also, it is 1 by 2 here. Here minus 18 cancel, 9 into 1, 9 into 2 here. So that means it is 1 by 2. So let us compare all this. a1 by a2 is equal to 1 by 2, b1 by b2 is equal to 1 by 2, c1 by c2 is equal to 1 by 2. That is a1 by a2 is by V2 equation arises like this. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. That means when we are taking the graph, it must be a constant line. It has infinite solutions, and those are the dependent pair of linear equations. So that means these pair of linear equation in two variables are the dependent pair of linear equation. Dependent pair of linear equations in two variables. Linear equations in two variables. Yes. So when the comparison of ratios of coefficient arises like this means it's a dependent pair of linear equation. So let us move on to the next problem. Yes. The second equation is 5x minus 4y plus 8 is equal to 0. Then 7x plus 6y minus 9 is equal to 0. It is equation number 1, and I will take this equation number 3. Firstly, we have to take the standard form of pair of linear equation to variable, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. I will take this as equation number 3. So after that, what we have to do? We have to compare equation 1 with equation 3 and equation 2 with equation 4. Then compare equation 1 with equation 3 and equation 2 with equation 4. So how can we compare? So here we have to compare equation 3 and equation 1. We have to write the coefficients. That is a1 is equal to 5, b1 is equal to minus 4, b1 is equal to minus 4, then c1 is equal to 8. C1 is equal to 8. Then here, when we have to compare equation 2 with equation 4, so here a2 is equal to 7, a2 is equal to 7, then b2 is equal to 6, b2 is equal to 6, then c2 is equal to, in place of c2 we have minus 9. After that, we have to divide a1 by a2 and b1 b2 and c1 c2. That is, firstly a1 by a2 we have to take 5 by 7, because in place of a1 is 5. Then b1 by b2, b1 is minus 4, and b2 is 6. So that means we have to simplify that one, that is minus 2 by 3. So b1 by b2 is equal to minus 2 by 3. So then take c1 by c2. c1 is 8, and c2 is minus 9 is equal to minus 8 by 9. So then observe all those quantities. a1 by a2 is equal to 5 by 7, b1 by b2 is equal to minus 2 by 3, c1 by c2 is equal to minus 3. None of them are equal. So then we have to write a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2. So here we have the condition a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2. That means when we are taking the graphical representation, it's a intersecting line. Those equations are having only one common solution. So those pair of equations are the consistent pair of linear equations. These pair of linear equations in two variables are called consistent pair of linear equation. Consistent pair of linear equations in two variables. So this is nothing but the consistent pair of linear equation. The consistent pair of linear equation we get like this. So let us move on to the next problem. Third equation is 3x plus 6y is equal to 5. 3x plus 6y minus 5 is equal to 0. And then 2x plus 4y minus 7 is equal to 0. So here we have to take the same procedure. Here I will take equation number 1 and equation number 2 here. So after that we have to take the standard form of the pair of the equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Equation number 3 and equation number 4. So after that we have to compare equation 1 with equation 3 and equation 2 with equation number 4. So what we have to do? So we have to take the value of b1, b1, c1 and b2, b2, c2. So firstly a1, in place of a1 there is 3 and in place of b1 there is 6. Then in place of c1 there is minus 5 and then in place of a2 is 2. Then in place of b2 is 4. Then in place of c2 it is minus 7. Yes. So after that what we have to do? We have to take the ratios of a1 a2 b1 b2 and c1 c2. So here a1 by a2, a1 is 3 and a2 is 2, that is 3 by 2. Then we have to take the value of b1 by b2, that is b1 is 6 and b2 is 4. So we can write it as 3 by 2. Then c1 by c2, c1 is minus 5 and c2 is minus 7. This is equal to 5 by 7. Then we can compare. So here a1 by a2 and b1 by b2 are 3 by 2 but not a1 by b2. a1 by b2 is equal to b1 by b2 is not equal to c1 by c2. So here the case arises like this, that is a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So these are the parallel lines. So the parallel lines, there is no solution. So you do the common solution for the pair of variable, and those are the inconsistent pair of linear equation. It means these pair of linear equation two variables, these pair of linear equations in two variables are inconsistent pair of linear equations in two variables. Yes. So that means we understood the three major conditions of this concept, that is consistency, inconsistency and dependency. So when the ratios of coefficients holds this condition, so it is consistent pair of linear equation. When the pair of linear equation holds a1 by a2 is equal to b1 by b2, c1 by is equal to c1 by c2, it is independent pair of linear equation. And here when the pair of linear equation in two variable holds this condition a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, it must be a inconsistent pair of. So I hope you enjoyed it. So I conclude this part here. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the icon. So thank you one and all. Be safe and stay home. Thanks.